So in the previous video, we established that if a function is even, then it cannot be odd. If it's an odd function, then it cannot be even. So now you only need to check for one. If this is true, then you don't need to check for this. If this is true, then you don't need to check for this, unless you have a silly function like this. Then this is the only function where it could be both even and odd. So from now on, when given a function here, um, if it's an even function, then you don't need to check that is an odd function. Yeah, you don't need to check it. If this is true, then you don't need to check that it's an even function. It can only be one. It can't be both, unless it's this silly function. Okay. Well, anyway, it's your turn to have a go now. So is this function an even function, an odd function, or is it neither? So press pause and have a go. Okay, so let's check if it's even. So let's apply this transformation here. So hang on, f of minus x here equals. Now put this into here, and also put this into here and into here as well. Okay, so this would be minus x to the power of 3. And then minus and then you've got this minus x squared in here, and then minus x minus x in here, and then minus 2. Okay, so let's tidy this up. So this then becomes this whole thing here becomes negative x to the power of 3, and this remember that you have to do this first. And then you take into account the negative sign. So doing this first will give you positive x squared, and then you've got a minus here, so it would be minus x squared. Okay, and then here you've got a minus in here and a minus out here, so it will be positive x, and then this is just a minus 2, so minus 2. So starting out with this function here, when you apply this transformation here, it then becomes this. And then but then the thing is, this after our transformation here, this thing does not equal this thing up here because of this minus here, and then this is also different. So this here, so after applying this transformation, it does not equal our original function. So therefore this is a symbol for therefore. Therefore it's not even. Okay, so let's check if it's odd. So let's apply. We just applied this transformation earlier, and it turns out to be this. Hang on, it turned out to be, what was it? Minus x to the power of 3. What was it earlier? It was minus x squared, and then plus x minus 2. Now let's apply this transformation here. So everything remains the same, and then you stick a negative in front of it. So us applying this transformation here, minus f of x here, that equals, everything stays the same. So bracket, everything stays the same, and then later on we will stick a negative in front. So everything stays the same. So that's the whole thing staying the same. The whole function staying the same. Okay, and then we would stick a negative in front of it. So let's tidy this up. This will then become well, this and this would be negative x to the power 3, and then this will be plus x squared, and then plus x, and then plus 2. The question is, well, does this equal remember that this is here, minus f of x. Minus f of x is here, so this thing here is this thing here. Now this transformation here is this here. Okay, so this thing is this thing here. So the question is, Well, are these two the same? That's what when we're checking this here, we are really asking, is this exactly the same as this? Well, look at the two, positive, negative. This is good, but the point is that it's already different. This one here is different from this. Um, yeah, well, these two are not the same. So it's not. So this function here, our original function, is not even and it's not odd. Okay, so it's neither. Okay.